In this video, we are going to talk about the graph and charts, and we'll be talking about proportion, percentage, even we talk about a rate. Those are very basic ways of presenting a data distribution. Okay, so first of all, let's talk about the frequency and the proportion as well as the percentage. The frequency is very easy to understand. It's just a simple raw count. Okay, when the proportion is that we standardize the form of a frequency that ranges from 0 to 1. When the percentage, everyone knows a percentage, right? Percentage is the one that from the 0 to 100. So the proportion and percentage are basically represents similar things. They have slightly different meanings, but most likely they are referring to the same thing. Okay, it's just different way we say it, and whether the audience, which one they can accept. Somebody are more likely to understand what is the percentage instead of the proportion. So the frequency and the proportion are can be the proportion can be calculated based on the frequency. Okay, the formula is quite simple. The proportion equals to the frequency divided by the total sample size. Now again, you can see the frequency within the sample size, so it cannot be larger than the sample size. Now maximally it could be the same as the sample size, but it definitely cannot exceed the sample size. For example, we have a set 100 people, 100 college student, and you say the frequency of female student is 101. So, which doesn't make sense, right? If you have 100 student sample, the highest number of female student you can have is 100. So therefore, the proportion will be between 0 to 1. Okay, if you have calculated some proportion is larger than 1, or it's a negative number, that means there will be some problems. So for the percentage, it's more easy to understand. It's just the proportion multiplied by 100, or the frequency divided by the sample size multiplied by 100. Okay, there are no other particular things about the proportion or the percentage. It's a very simple way to present data distribution. So here is an example. Like in this example, we have male and female. Maybe they're student, maybe they're not. I don't know. But we have the frequency of the male and the frequency of the female. And if you add those two things together, you will get the total sample size, right? So based on the previous formula, we can get the proportion of the male by using this 25,000 divided by the 52,000. Okay, that would be 0.48. If you multiply that by 100, you will get a percentage around 47, 48%. Now you can do the similar thing for the female, then you will get 0.52 for the proportion for the female, and around the 52% that in this sample are female. Right? Now to be noticed that when you're going to do the calculation, you have to make sure the proportion of male and the proportion of the female, the sum of them is supposed to be 1. If you add them together, it's supposed to be 1. Similar to the percentage, if you add them together, it's supposed to be 100%. Okay, that's the one you pay a particular attention to when you're doing the calculation on proportion and percentage. So I use the fast food. I like fast food. I like KFC. I usually eat KFC Monday, Wednesday, Taco Bell Tuesday, Thursday, and Burger King on Saturday. And Sunday, usually I like the prime rib in Texas Roadhouse, so I just use them. These are the data. I forgot which year it is, but these are the data that how many restaurants across the whole world, right? So you have like almost 4,491 KFC restaurants across the whole world. You even have more in Taco Bell, and you have more in Burger King. Now, based on these three numbers, so you can post a video and to try to calculate the total sample size and also the proportion of each of the each of the fast food restaurant, and also the percentage. So here's the results, right? So in order to calculate the proportion, the very first thing you have to do is to calculate the total. So by adding all the three together, you get a total. Then everything become more easier. So the KFC proportion, the proportion of KFC is just this 4491 divided by 18,000. It will get this 0.25 multiplied by 100 will get a percentage around 24.83 or 25%. Okay, you do the same thing for the Taco Bell and Burger King. And again, make sure that when you finish your proportion, you add everything together is supposed to be 1. And when you finish your percentage, you add everything together, it will be 100. And now we go into the cumulative frequency, proportion, and percentage. Okay, so cumulative measures obtained by adding a given number to all the numbers below it. Okay, below it. So the way that we do is that the frequency distribution give you frequency, proportion, and percentage. But sometimes when you try to answer some questions, it may be a little bit difficult because you need some extra calculation to answer those questions. This is where the cumulative frequency, cumulative proportion, and cumulative percentage come in. So I show you in this particular examples. So let's say we interviewed some people and we get how many times they have been victimized in the last year. So simply from this table, you can see that there are 639 people who has not been victimized. They are really lucky. And 78 people who has been victimized one time last year. And there are 8 people who were super unlucky that they have been victimized twice last year. Okay, so we have the frequency. Okay, we calculate the proportion and also the percentage. To calculate that, we need to add those three things together to get the total sample size is 725, right? Then you for this 88, you just use like 639 divided by 725, you will get 0.88, and multiply by 100, you will get this percentage. Now, the cumulative frequency, cumulative proportion, and cumulative percentage is used when you're trying to answer the question like, how many people got less than one or one victimized, or how many people have been victimized one time or less than one time in the last year, right? So to understand, to answer the question, you need to add the people who has not been victimized and who has only one victimization. So when you add those two things, so you basically add those two things and to give you the answer. Now, cumulative things is that it calculates this for you. Okay, so you can simply say that there are 717 people who has been victimized only one time or not even being victimized in the last year. And if you add those 8, going to is that there are 725 people who has been victimized 2 times or less than 2 times in the last year. Now, since the 2 is our like the highest one, this 725 is also represents the total sample size. See, that's the same number, 725. So by doing this one, you will give people like a good way that to answer those questions like at least or um, or less than, those kind of questions. Okay, so another question is like what's the percentage of the people in this sample that has been victimized only one time or less than one time? So it's easy, you can see one time, only one time, so you are looking at and the percentage, right? The question asks us about the percentage. You go to the cumulative, so you say about 98.9, almost 99% person who has only been victimized one time or even not been victimized in the last year. This is the most like the useful thing about the cumulative frequency, cumulative proportion, and cumulative percentage. Okay, rates. So the rate is a method of standardizing that involves in dividing the number of events by the total population, and which we focusing on is the population, the frequency divided by the population. Okay, so most likely is the frequency is so low, like this paragraph says, the frequency is so low, so when it's divided by the population, the number becomes super small. So the solution to that is that we always multiply by some 10,000, 100,000, even 1 million to get a better interpretation about the rate. Okay, in criminal justice or other social sciences, sometimes when you talk about the frequency, absolute number, it doesn't make a lot of sense, or it's not really kind of meaningful. It just gives you an absolute number. So what you're gonna do is that you are going to use the rate to make it more meaningful. Now the question, I give you the example first here, and I'm going to interpret why this is more meaningful and why this is more useful in a next slide. But first of all, let's take a look at this thing. So in 2012, there are this kind of much burglary happen in the US, and the US population is this one. So when you're going to calculate the burglary rate, it's very easy. Is that use the frequency of the burglary divided by the total US population, you will get a rate. It's about 0.01. This is very small number, and you can hardly interpret. So it's like a 0.01 burglary happened to one people. It doesn't really make sense, right? So we multiply them by 10,000 or 10,000 people. You can use 100,000, it doesn't really matter. So you will get a better understanding number is 67. So which basically means like if you put 10,000 people in a place, and based on the US average burglary rate, there are supposed to happening 67 burglary crimes in a year. Okay, or you can say like 67 burglary will happen in a population of 10,000, or on average. Okay, some places could have more, some places could have less, but it's on average. So by doing the similar thing for the theft and the motor vehicle theft, you can see the theft is almost 200 and the motor vehicle is like 22. You will have the same a general sense about, well, this crime is more serious or this crime is less serious. Okay, now this example gives you a good understanding of why rate is so important. So if you take a look at the four states, Alabama, Texas, Delaware, and Michigan, and take a look at their frequency of property crimes, you can see like Texas, wow, has lots of property crimes. It's even more than the sum of the other three, right? So if you add the other three together, it's even less than half of the Texas. So the question is like, is this really happening that the Texas has a very serious problem about the property crime among those four states? The answer could be yes, or the answer could be no, right? However, when we ask these questions, we have to control one variable. The variable we have to control is the population, because a common sense or in general, we know that if there are more people, there will be more crimes, right? So if you take a look at the population, wow, Texas has a huge population other than other three states, right? So what do we do? So we calculate the rate per 10,000 people to control, sort of statistically control the population and to see what's the situation, true situation here. Now, it's very easy that you use the frequency divided by the population for each of the state, right? Then you're going to get the rate per 10,000 people. The interpretation is a similar thing compared to like the previous slides. So for in Alabama, there are 350 property crime happening on 10,000 people. In Texas, there are 279. In Delaware, there are 334. Now, when you kind of control the population, you can see here is that, well, Texas is not really the worst place that has lots of property crime, right? Just based on the rate, the Alabama maybe have the highest property crime rate among the three states. of or 4 states, right? Or even the Delaware is ranked the second. Okay, Texas is only like the third place. So you can see here is that when you're going to show people the absolute number, well, it's horrifying, but is this actual number actually represents the property crime problem in Texas, or it's just simply because of the population, right? So by simply using the rate, we sort of say, right, if we don't really consider other factors, then it might just coming from the population. The Texas has too many population that it causes has a lot of property crimes. The crosstabs. The crosstabs shows like how two variables overlap. It's a table that shows two variables at the same time. So most likely or most often I call them the crosstab. It's easy to say it. And the overlap between the two variables will be shown in this like example. For example, this is a very easy one. We have a sample size about 155 students, and from this sample size I have two variables. One is the gender, one is the whether they have the vehicle, right? It's easy. Gender, we have male and female. Vehicle, we have yes, I do have a vehicle, no, I don't have a vehicle. So to read this table is quite easy. So just answer some questions like how many male students have vehicles? 493, right? How many female students don't have vehicle? 447. How many male students don't have vehicle? 782. How many female students have a vehicle? 233, right? So you can see it's a very easy to read, and it can put two variables on the same table at the same time. In order to like test whether male may have more vehicles than females, or there is a relationship between the gender and whether they have the vehicles, we are going to talk about that in the chi-square test in the future PowerPoints. Okay, so and you will learn that gender is a nominal variable, having vehicle is a nominal variable. So two nominal variable means two categorical variables that we are going to use the chi-square to run the hypothesis test, but that's in the future. Okay. So in this second table, you can see it's a reporting crimes, percentage of victim report based on the male, female, and the type of the crimes here, right? So you can see like for the rape, sexual assault, about 40% of male victims choose to report. Female victims, only 23 female victims choose to report. For the robberies, about like 63 male victims will report to the police, and also about 62, similar to the male student among the female, will report. 60% female victims will report the crime to the police. For the assault, is similar. They too look really similar, but the difference here is like the sex crime, right? The rape and sexual assault. The male victims are there are more male or percentage on male victims to report rape and sexual assault than female victims. Okay. So let's talk about the chart and the graphs really quick. So because it's very easy to read a chart or a charts or a graphs if they are created in a reasonable way. So the most common way we do is apply bar, histogram, and also line graphs. Those five are the most one you will see. The last two are kind of similar. Okay, and it's a way that you represent a variable, represent the data distribution. Okay, it just gives you a visual picture about how this data look like. So for categorical data variables, most likely we are going to use the pie charts and also the bar chart. The categorical variable are basically the nominal variable or the ordinal variable. It's not represented by the numbers. Okay, the chart can be made from the frequency, proportion, percentage, and the easy way to see that is just test if you can read reader chart, right? It's a pie chart. It's very easy to read. It's like the race of stop drivers based on the percentage. So you will see like here we have 80 um, 80 percent stop drivers are white, about 12% stop drivers are black, 2.7 are Asian, and also we have 5% are some other races, right? So if you just know how to read it, it's very if the chart, if the picture, if the graph is made correctly, then it is very easy for the readers to read the information from it. Okay, the bar chart is a similar thing, like a percentage of victim report a crime to the police, right? We can see the simple assault is about 40%, and the aggravated assault is about 60, right? We have robbery is about 54, burglary about 54, and the motor vehicle theft is about 76. Of course, somebody steal my car, I definitely going to call the cops. I don't know why people don't, but I definitely going to do that, right? But for some other things like a simple assault, I would think it's just a small fight. If nobody going to get hurt, I'm not going to call the cops. And also it shows like 40% people choose to call the cops, means 60% people well think it's just simple style. It's just like a bar fight. It's something. It's nothing. Okay. And also robbery, burglary. You can see it's very easy to read it if those charts and the graphs are made in a good way. So for the continuous data variables, most likely we are going to talking about the interval and ratio variable based on our previous one. If you can use a ratio a variable, then that's great. Okay, if you can collect data for like based on the ratio variable, that would be great. So you can see the this is a histogram, right? You can see this is the percentage of people who commit crimes. You have the age, bottom from 10 years old to 40 years old. And then also each of the bar, it looks like a bunch of bar charts get together, right? Each of the bars suggests like the percent of people who commit crimes. So for example, in this 10 years old, it look like 3% of 10 years old kid commit some kind of crime, or we call them like delinquent behavior. For the kid who age 11, it goes to like around 4%. 12 is like about 6%. And if you take a look at like the 16, that's like 13%. That's a lot. Okay. This is also a classic curve, look like this, right? Classic curve in the criminology called the age crime curve. It's a classic one because you can see like lots of the crimes are committed by the people with like really teenagers. Okay, so when people getting old, they are not really into committing crimes or whatever. Okay, so people from like 13 to 19 or 14 to 18 years old are the one who usually commit lots of crimes, right? So the difference between the bar chart and histogram, these are not so big difference. So in the histogram, the bars are connected. As you can see here, bars are connected to each other. In the bar chart, they are separate because the age is a continuous variable. So that means they are continuous, like a connect to each other, right? But in the previous bar chart, they don't connect each other because they are not continuous variable. The distance is meaningless. What's the meaning of a simple assault and aggravated assault and the distance between the aggravated assault and robbery? It's meaningless, right? But for the age, there is a meaning because there is only the distance is always like a 1 years old, 1 years old, 1 years old. That's why what they are connected and another in the bar chart they are separated. Okay, and most likely in the histogram, the bars are placed on from the lowest to the highest, as you can see here, from 10 to 40. But in the bar chart, it's arbitrary. It basically means like, well, in this example, you can move the motor vehicle theft into here, or you can move the simple assault in the middle. It doesn't really make a difference. Okay. And also you can have the line graphs. If we have the continuous data, we can also show them the line graphs. So see, this also represents the percentage of people who commit crime. The X represents the age. The Y represents the percentage, right? Does that look familiar? This age crime rate, age crime curve, right? It's the same about like the histogram here, but it's just a different way. So this one we just use a line to show each of the how many or the frequency or the percentage of each age. And similar for the line graphs, we just don't have those little dot here, little dot here. We have the line, but it more close look like a curve like this, right? The crime age curve. So some of the difference between the histogram and another line chart is there is no big difference. So we don't really pay attention to this one. It really depends like how you want your data look at. So you can use this one to show your data. You can use this one to show your data. You can even use a histogram to show your data. It just depends on your personal interest, your personal preference. Okay. So another thing is for the group data, right? So the overall purpose of the frequency distribution chart graph is to display its data in an accessible and understandable format. Please do not give me a table or a chart or a graph that makes things worse. Like you can't even know what's going on in this chart, or you use the wrong chart to make it's really hard to read the chart. Okay, so sometimes like displaying data is difficult, or the data does not lend itself to be displayed. So we can kind of group the data to find a more sort of patterns, right? When we're going to do this, for example, when we're going to do this line chart, the purpose for this one is to display the data and also take a look at some patterns, right? The patterns we found out here is that young people tend to, or there are young people tend to commit more crimes than older people. That's a simple one, right? So we try to make looking for some patterns, and the data displacement, data distribution, it's easy for us to find out those patterns easily. So let me give you this one. What's a pattern in this table? I have age from 16 to 50, right? Each of the age has a frequency. So in this here, here, here. So basically means like I have one person 16, seven person 17, four person are 18 years old, nine person are 19 years old, eight person are 20 years old, blah 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 blah. Now the thing is like, tell me what's the pattern. Well, it's really hard to find out because you are facing so many numbers, right? But what if we illustrate them? Okay, when we make this look like a bar chart or a histogram, whatever, you look like, um, well, it look like the shape look like this, right? But still, it's really difficult to see like, well, what is this pattern, right? Or is this pattern really working, or how to interpret this pattern or whatever? It's really hard. So the way is that we can group the data. For example, we can set up, it's really based on your discretion, age range like from 16 to 23, we go into group 1, and 24 to 32, we go into group 2. Okay, I'll make sure that the boundary are not overlap. You cannot put a 24 here because if you put 24 here, there is another 24 here. So a person who is 24 will be calculated both in the group 1 and group 2. So it's not going to be exhaustive. So it's not right. Okay, make sure that each of them are connected but not overlap, like 32, 33, 41, 42, something like that. So you can go back and pause the video, go back to the previous this one, and based on this age range, and make sure add those frequency together. So that's the thing you will get. So the frequency I have found out by using this age range. Of course, I set up this age range by myself. There's no good reason. You can even like add another group over here and make the range like a smaller to see what's the thing. But when we add those things together, you can see like I have group 1, 45 people in the group 1, 38 in the group 2, 18 in the group 3, 28 in the group 4. So now you're going to use a bar chart or whatever chart you're going to illustrate. You can see the pattern is that we can find a pattern is like, look like young, there are lots of young people and there are less older people, but also the most less frequency comes from like 33 to 41 groups. It just help you to find some patterns. If you're using a different age range, you may find a different patterns. That's what I mean. Okay, it really depends on your discretion. That's it.